But it means that, one, you can't use tin-plated electronics in space, or you typically don't. It's a bad idea because you end up with these long whiskers that will just sort of branch out and poke something adjacent. And for DFMEA's sake, what it means is, like, I don't know, a tin whisker can be pretty thin. So if it's a high current thing, you might not care because it'll just blow up your tiny little fuse and continue unbeknownst to anyone. But if you have a signal, for example, it could bias something in the wrong direction. It could falsely tell you something about that signal, that you're in an overcurrent situation or whatever. And you might, for example, blow a pyro and disconnect a pack, destroy a product, basically speaking, because you don't know. So typically with the DFMEA, there's two things you're looking for. It's like, what would happen? And then, is there a way we can detect this failure mode? And if there's a way you can detect it, you can kind of subvert some of the worst effects and continue. And therefore, that's, you space out your redundancy. You don't put things adjacent to one another, such that if it's either tin whiskers or crud, basically, some FOD getting in there, some debris.
Very interesting. So to automate this process of DFMEA, you would kind of like run some kind of static analysis that would test shorting pins together and make sure there's some kind of failure protection?
Ideally, or detectability, as I said. Like that can be your outcome kind of mode.
I see.